In the last video we showed that a pair of equations of this form represent a circle. HK is the centre of the circle, R is the radius of the circle. XY are the coordinates of any point on the circle. Theta is the independent variable or parameter. So both x and y depend on this single parameter theta. If theta is in degrees, it runs from 0 to 360 degrees. So if we take all the values of theta from 0 to 360 degrees, we will generate all the points xy on the circle. In this example, we want to show that the parametric equations x equals minus 3 plus 6 cos theta and y equals 8 plus 6 sine theta represent a circle, and we want to find its centre and radius. Well, by comparing these equations to these ones over here, we can see straight away that these equations must represent a circle, because these equations have exactly the same form as these equations over here. We can see in particular that the number in front of cos theta and sine theta is the same. And that's what we need. These numbers must be the same if this pair of equations represents a circle. And then we have the numbers h and k. Well, h is minus 3 in this case, k is 8. So we can see that these equations have the same form as these, so these equations must represent a circle. The radius is 6, and the centre hk is minus 3, 8. Now, if you don't know anything about this general form of the parametric equation of a circle, we can still show that these pair of equations must represent a circle. All we do is we take each equation and rearrange it to try and get cos theta in terms of x and sine theta in terms of y. So if we rearrange the top equation, we see that x plus 3 over 6 equals the cos of theta. And rearranging the second equation to make sine theta the subject, we have y minus 8 divided by 6. Now, as we saw in the last video, we can square both sides of these and sum them, and then use an important identity. So we get x plus 3 over 6 squared plus y minus 8 over 6 squared equals cos squared theta plus sine squared theta. And we know that cos squared theta plus sine squared theta equals 1 for all values of theta. So we can just replace that with 1. So all I did was square both of these equations and add the left-hand sides together and the right-hand sides together. And by multiplying everything here by 36, we get x plus 3 squared plus y minus 8 squared equals 36 times 1. So here we have the equation of a circle. How do we know that this is a circle? Well, it's got the form x minus h squared plus y minus k squared equals r squared. So we saw this before. It's the general equation of a circle with centre h, k and radius r. And we can read off the centre. We just change the signs of these two values. So h is minus 3, k is plus 8, as we have up here. And since r squared is 36, r must be the square root of 36, which is 6. Now let's look at this example here. We see that these equations do not have the general form for the parametric equation of a circle. We will have to approach these a different way than trying to get them into this form here, although we could probably get them into this form, but I won't do it that way. What I will do is I will get cos theta in terms of x and y and sine theta in terms of x and y, and then I will use the identity cos squared theta plus sine squared theta equals 1. So this is the key identity. So we need to make, say, cos theta the subject. If we just add these two equations together, you can see that the sine theta terms will cancel out. So let's do that. If we add the left hand sides, we get x plus y. If we add the right hand sides, we have 1 minus 3 is minus 2. 2 cos theta plus 2 cos theta is 4 cos theta. So now you see we have an equation which will give us cos theta in terms of x and y. So if we rearrange this, we get cos theta equals x plus y plus 2 all divided by 4. If we subtract these equations, we can actually eliminate the cos theta terms, because you see we have a 2 cos theta and a 2 cos theta here. So if we take the top equation and subtract the bottom equation, we'll have x minus y equals 1 minus minus 3, which is 4. These will cancel out. 2 sine theta plus 2 sine theta will be 4 sine theta. So we can make sine theta the subject here, get sine theta in terms of x and y. So we get sine theta equals x minus y minus 4 divided by 4. So now we can apply this identity. And by applying this identity, we will get a Cartesian equation connecting x and y. So here is our Cartesian equation. We need to show that this is the equation of a circle. For it to be the equation of a circle, it has to have the form x minus h squared plus y minus k squared equals r squared, where h, k and r are constants. It has to have this form. See, when we square these fractions, we're going to get 16 in the denominator, so we multiply across by 16. So we'll have 16 times 1 on the right hand side. We have to take x plus y plus 2 and square it. Well, we can break this into a binomial consisting of the two terms x plus y and 2. So we square the first term, x plus y squared is x squared plus 2xy plus y squared. Multiply the first by the second and double, so we get 2x plus 2y doubled is 4x plus 4y. Then square the second term, 2 squared is 4. And we do the same here. So we look at x minus y minus 4, think of it as a binomial consisting of two terms. One term is x minus y and the second term is minus 4. Square the first term. So we have x minus y squared. That's going to give us x squared minus 2xy plus y squared. Multiply x minus y by minus 4 and double. That's going to give us minus 8x plus 8y. And then we square the second term, which is minus 4. Squaring that gives us plus 16. Now, 16s cancel out. Let's look at the squared terms. We have 2x squared plus 2y squared. If we look at the x terms, we have plus 4x minus 8x. That's minus 4x. If we look at the y terms, we have plus 4y plus 8y. That's plus 12y. And the xy terms cancel out. Just a plus 4 left. We have 0 on the right hand side. We can divide everything by 2. Now, is this the equation of the circle or not? Well, we can see that the general form of the equation of a circle is x minus h squared plus y minus k squared equals r squared. Of course, we can expand this out. And we can actually write this as x squared plus y squared minus 2hx minus 2ky plus some constant equals 0. Now, the constant is going to be made up of r squared and h squared and k squared. I explained this in a previous video. So I should have written down the expanded form of the equation of a circle. And does this equation have this expanded form of the equation of a circle? Indeed it does. We look at the coefficient of x, and from that we can get h. We look at the coefficient of y, we can find k from that. We can also find the radius. I explained in a previous video that the radius is root h squared plus k squared minus c. So when we know h, k and c, we can get radius. C is the constant term at the end. So we can see that this equation does indeed have this form here. We have an x squared term, a y squared term, an x term, a y term, some constant equals 0 on the right hand side. So to find h, we have the coefficient and change the sign. So we see that h equals 1. K equals half the coefficient of y, with the sign changed, which is minus 3. Minus 2k equals plus 6, so k equals minus 3. And as for the radius, well, we have the root of h squared plus k squared minus c. C in this example is 2. So this is root 1 plus 9 is 10 minus 2 is 8. So we have a circle whose center is 1 minus 3 and radius is the square root of 8. Now let's take a different type of example. This example does not involve the parameter theta, where if you remember from the previous video, theta is measured anti-clockwise from the positive x-axis to the radius line of a circle. So the radius line connects the fixed center hk to point xy on the circle. That's not the situation here. So this point will belong to a circle if the connection between x and y follows the equation of a circle. We know that if xy is a point on a circle, then it has to satisfy an equation of this form. And if it does satisfy an equation of this form, then we can read off what the center of the circle is, and we can work out the radius from hk and c using this formula here. So we have to prove that a point of this form will satisfy an equation of this form. So what we need to do here is make t the subject of these equations in some way. If we can get t in terms of x in each of these equations, then we can equate the results and we will have an equation connecting x and y. And hopefully that equation is the equation of a circle. So let's just do that. Let's multiply both sides by 1 plus t squared and isolate the t squared term in this equation. So we can take t squared out of this. If we take t squared out of this, we'll have t squared times x minus 1, and we divide across by x minus 1. So t squared is equal to this, so to get t, we look at the square root of this. Now, we could try and get t in terms of y here, but it's going to get really complicated because we're going to have to square out this here. It might actually be easier to plug this expression in for t in this equation here. So for t we have the square root of 3 minus x over x minus 1. And we have to take the square root of 3 minus x over x minus 1 here and square it. Now we have an equation connecting y with x. So we need to square out what's inside the brackets here. We square the first term to get this here, multiply the first term by the second term and double to get this term, then square the second term to get plus 1. Underneath we just have to square this quantity, just get rid of the square root sign. Now in case you're worried about the plus or minus, I might just indicate that. We could take the positive or negative square root. Let's just put that in for now. Of course, when we square this term, it doesn't matter whether we have a plus or a minus. We will just get this quantity here. However, when we're multiplying this term by this term and doubling, we could have a plus or minus, so I'll just stick it in there for now. Underneath, when we square this, it doesn't matter about the plus or minus, because when we square something, we always get something positive. Now, let's see what we can do with this. We should try and isolate the term involving the square root. We want to get rid of a square root because the general equation of a circle does not involve a square root, so we're going to try and isolate this so then we can square both sides to get rid of it. We can't obviously square both sides here, that's not going to help. Let's combine these two fractions in the denominator. So we have 1 over 1. 1 goes into x minus 1 times. X minus 1 times 1 is x minus 1. Or we can think of the number 1 as just being x minus 1 divided by x minus 1. And the other fraction, from the other fraction we get 3 minus x up here. So, and these x's cancel, that's convenient. So we've 3 minus 1 is 2, we've 2 over x minus 1. On top, let's combine 3 minus x over x minus 1 with plus 1. Well, we just get the same result as we got underneath. That's 2 over x minus 1. And then we have the square root term, which can be positive or negative. I'll just stick in the plus or minus sign again, just in case you're worried about that. We will see that it won't matter at the end because we're going to be squaring this term. Now we can divide above and below by 2. And we can also multiply above and below by x minus 1. We multiply by x minus 1 underneath, we just end up with 1 underneath. X minus 1 times 1 over x minus 1 gives us 1. And we have to multiply x minus 1 by the square root term. So we end up with this here. Of course, the square root term could be positive or negative, but you'll see now in a minute that it doesn't matter because we're going to be squaring. So what we do is bring over the 1, so we have y plus 1 on the left hand side. And then we're going to square what's on the right hand side. So I'll show the squaring now. Actually, we're going to square both sides now. So we square the minus x minus 1. Well, that's just x minus 1 squared. Squaring the minus sign makes it positive. And then we have to square this thing, so the plus or minus doesn't matter. We get 3 minus x over x minus 1. So x minus 1 cancels with one of the x minus 1's on top. And we now have to expand this out. Y squared plus 2y plus 1. Multiplying out the left hand side, we will get a plus 3x and a plus 1x. That's going to give us a plus 4x. And we have x by minus x is minus x squared, and we have minus 1 by plus 3 is minus 3. So if we bring everything to one side, we get x squared plus y squared minus 4x plus 2y. We're going to have plus 1 and plus 3 is plus 4. Well, this is the equation of a circle. It's got the form x squared plus y squared minus 2hx minus 2ky plus c equals 0. So, that's what we have to show. We have to show that this point lies on a circle. Basically had to get the relationship between x and y. And this is the relationship between x and y. It's got the form of the equation of a circle. We could go further, of course, and get the center and radius. I'll just write down the center. Actually, I'll finish it. The center is got by halving the coefficient of x and changing the sign. So minus 2h is minus 4, so h is 2. To get the y value, minus 2k is 2, so k is minus 1. And to get the radius, we have to get the square root of h squared plus k squared minus c. H squared plus k squared is 5 minus c. c is 4. 5 minus 4 is 1, so we have the square root of 1, which of course is 1.